Hey there, Mr. Weaver here, and this is topic 7, lesson 1, naming and ordering polynomials. After this lesson, you need to be able to reorder polynomials into standard form. You need to be able to determine the degree of a polynomial, and then you need to be able to name polynomials by degree and term. You'll know you're successful after this lesson if you can order the terms from highest degree to lowest degree to put the polynomial in standard form, if you can determine the degree of a polynomial, and if you can use the highest degree and the number of terms to name the polynomial. First, before we get into some vocabulary here, I do want to point out that many times when I'm saying the word polynomial, it's going to mean more in a general sense of any of these things, regardless of how many terms or what the degree is. But once we get to naming, then the word polynomial becomes more specific. You'll see when we get there. So first, we have standard form of a polynomial. If a polynomial is in standard form, that just means that it's in order from the largest exponent to the smallest exponent. So here, if we were given this polynomial or this group of terms, this is not in standard form because it starts with 6 and then a little bit later the exponent is 8. It's not in order from the largest exponent to the smallest. So if I wanted to put it in standard form, I would take those exponents, knowing that if there is no variable, it's a 0, and if there is no exponent, it's a 1. Notice the two parts that are in orange. We have x to the 0 and a 1. I put those there so you can see how they relate to the others. So when you don't see a variable at all, that's like having no x's, no variables. So -8 there has 0 x's with it. When you see no exponent, like that 1 there, -3x doesn't have an exponent, but there's still 1x involved in that situation. So when I'm putting them in order from least to greatest, I need to think of those as 1 and 0. So standard form here would be 3x to the 8 plus 5x to the 6 plus 9x to the 4 and so on. Notice the exponent is decreasing, going from left to right. So it started with 8, which was the highest, and ended with 0, which was the lowest. Next, we're going to look at the two vocab words that are needed in order to name our polynomials. So first is terms. When you see the word terms, they're talking about the parts of the expression that are separated by that plus sign or the minus. Think back to previous lessons or previous grades when you were combining like terms. It's the same meaning here. The plus or the minus goes with the part after it. And if the first term doesn't have any symbol, it's a plus. So if we look at the ones from above, there's no symbol out front, so there's a hidden plus sign there. It's positive 5x to the 6th power. Or if we pick out anything between it, so that 3x to the 8, that plus sign before it goes with it. So it's positive 3x to the 8. Or we have negative 3x. So wherever you see the sign, it goes with that term after it. The other thing we're going to need to name our polynomials is the degree. So the degree is just the largest exponent in that expression. So if it's in standard form, it should be easy to pick out the largest. So if we go back to what we did earlier, putting it in standard form, which one's the largest? 3x to the 8th power had the largest exponent. So we would call that 8th degree. Now, we're going to look at some different words for degrees here in just a second, but in general, you can put whatever number it is, degree. So you could say a 2nd degree or a 5th degree or a 10th degree, whatever exponent is the highest. One caution though, some of the smaller numbers also have different words that go with it. Instead of saying like second degree, it has another word, which we will look at next. Now that we know what terms are and what degree means, when we're naming polynomials, we're going to go off of those two things and put them together to form one name. It's going to go degree first and then by the number of terms. So first, let's look at our degree. We have some words here that based on the degree, we are going to use to name it. So if the highest exponent is 0, then that is called a constant. So like just the number 8 is a constant. If the highest number is 1 with that hidden exponent, then it's linear. If the highest exponent is 2, it's called quadratic. If the highest exponent is 3, so it's a third degree, it is called cubic, or you might just see it as third degree. And then anything 4 or more, call it by the number degree. It's like the mathematicians who created this got kind of lazy, and anything over 4 is just what it is. So 4 is 4th degree, 5 is 5th degree, and so on. So here, if we had 2x to the 7th, that would be a 7th degree. The other part to this is the number of terms. So based on how many terms there are, it has a second word. So if it has one term, it's a monomial. So 2x to the 4 only has one term. This would be a monomial. It would also be 4th degree. If there are two terms, it's called a binomial. Bi meaning two, like bicycle. Bicycle has 2 wheels. This has 2 terms. 3, a trinomial. So here we have 3 terms. This is a trinomial, like tricycle. Tri, T-R-I, means 3. And then again, mathematicians got lazy, so 4 or more, they just decided to call it a polynomial. So here we have 4 terms. It is a polynomial. We'll look at naming them officially when we get to some of the examples later on. Let's look at a couple examples. So first, write the following polynomial expression in standard form. So we wanted to go by exponent from greatest to least. So we're looking at our exponents here. We have a negative 12 that does not have one at all, and we have 8x that doesn't have one either. Remember, the one with no x at all is a 0 power, and the one with just an x but no exponent is a 1. So now we're going to order those from greatest to least. Negative 2x to the 5th would go first. Remember, the plus or minus symbol goes with the thing after it. So that 2x minus 5, that minus would go with it. So I'm going to cross it out. That way I keep track of which ones I've used. Next highest exponent is the 3rd power. There was no symbol in front of it, which means it was a plus. So plus 7x to the 3rd. Cross it out. Next would be our plus 9x to the 2nd power. Then we would have 8x to the 1st power, so just 8x. And finally, we would have minus 12. So now I have them in order from largest exponent to smallest exponent. If you notice, the constant, the one without any variable at all, will always be last. And the one with just an x or just a y, whatever the only variable, that will always be second to last. The other ones will have exponents, and you should be able to put them in order a little bit easier. It's always that x and the one with nothing at all that are a little bit tricky. Now it's your turn. Pause the video and write that polynomial in standard form. Let's check. You should have got 7x to the 8th power plus 5x to the 4th plus 3x to the 2nd plus 4x minus 2. Since that first term, 7x to the 8th, was positive, when I rewrote it, I didn't need to write that plus sign, so I took it away. Next, let's look at finding the degree of a polynomial. If there's only one variable, so throughout the whole thing there's only x's or only y's or only a's, then finding the degree just means locating the highest exponent. If there's more than one variable, like there is in the first example here, 4x to the third, y to the second, z to the fifth, it's one extra step before finding the degree. So if there's more than one variable, what you're going to do is add the exponents. Now, be careful, you're only adding the things that are connected together. So in the first one, we only have one term. We're going to take all of the exponents from the variables and add them together. So 3 plus 2 plus 5 is 10. So this would be 10th degree. Let's look at the next one for a different kind of example. So here we have three terms. It's a trinomial. We have 6x to the third plus 6x to the 8, y to the 2, plus 3xy. When we're finding the degree of this type of situation where there's more than one term, we're going to choose the one that's the highest of all of them. So to determine that, let's figure out the degree for each term. So first one, we have 6x to the third. There's only an x there, so I'm just going to take that 3. That is a third degree part of this trinomial. If I look in the middle term, I have x to the 8 and y to the second. I would add those two together, so that part is a 10. For the last part, I have 3xy. Those both have a hidden 1 as their exponent. So those together would actually be a second degree part. Now, for the degree of the whole expression, I'm going to choose the one that's the highest. So this would also be a 10th degree. That middle term, 8 plus 2, was the highest degree of all of the parts. That's the one we're going to choose. Now it's your turn. Pause the video. Find the degree for each expression. Let's check. The first one is a 7th degree monomial here. So if you look closely, that b has a hidden 1. So 4 plus 1 plus 2, adding our exponents, would give us 7. So that would be 7th degree. The second one is a 6th degree. If we go through, the first one we had exponents of 4 and 2. So together that part would be 6. In that middle term, it's a 3. So that's third degree part. And at the end, we have a hidden 1 and 4. So that would be a 5th degree part. The highest one was 6. This is a 6th degree polynomial expression. Now let's look at our examples for naming. So we're going to name the expressions. To do this, we are going to take our degree and the number of terms in that order. So degree first, then the number of terms. So first, we're going to look for the highest degree. Here, it's already in standard form, so it should be on the left. If it's not in standard form, you might want to reorder it. But our highest degree here is 2. Now, looking back at the words that we need, if the highest degree is 2, the word we're going to use is quadratic. So this is a quadratic. Now, to get the second word, we are going to count the number of terms. So here, there are 3 terms. So 3 terms is called a trinomial. Now, when we put those two things together, we get the name of our polynomial. This is a quadratic trinomial. Both words together make that name, quadratic trinomial. Let's look at our second example. We have x to the 5 plus 6x to the third minus 8x to the second plus 9x. So again, we need our highest degree in terms. It's already in standard form, so the highest degree is 5. 5 would just be 5th degree, and there are 4 terms. 4 terms is a polynomial, just as a general sense. So this would be a 5th degree polynomial. Now it's your turn again. Pause the video one last time. Name the 2 polynomial expressions there. Let's check. You should have said the first one is a cubic binomial or a 3rd degree binomial. The highest exponent is a 3. That's where the cubic comes from. And there are 2 terms, which is where binomial comes from. The second one is a linear monomial. So just that x, or exponent of 1, is linear, and there's only 1 term there, so it's a monomial. This is a linear monomial. In this lesson, we learned about naming polynomials and standard form. When a polynomial is in standard form, it's in order from the largest exponent to the smallest exponent. When you put them in standard form, it's not only the correct way to write polynomials, it's also easier later to name them correctly when they're in order. While polynomial can be a general term, as I said throughout this lesson when I was calling everything a polynomial, naming them can also help us be more specific. So when we're naming, it involves the highest degree and the number of terms. A term is just a piece of the polynomial separated by a plus or a minus. When you want to name them, take the specific word that represents your highest degree and the specific word that tells you the number of terms. Together, they would name the polynomial. So for example, 3x to the second power plus 9 would be a quadratic binomial, since the highest degree is 2, which is where quadratic comes from, and there are 2 terms, which is called a binomial. All of the polynomials we're going to see in this chapter are going to follow the same patterns, so you're going to need to learn how they work, both with naming and with standard form. So after this lesson, do you now know how to put a polynomial in order from highest degree to lowest degree to put it in standard form? Do you now know how to determine the degree of the polynomial? And can you use the highest degree and the number of terms to name a polynomial? If you're not sure about any of these things, go back and look at the definitions and some of the examples to help deepen your understanding of this concept. And that's the end of Lesson 1 on naming and ordering polynomials.